In my previous two Pure Maths videos, translating graphs and stretching graphs, we learned how to apply transformations to graphs. Now today, let's take a look at how to transform functions. You can apply transformations to unfamiliar functions by considering how specific points and features are transformed. So first, let's take a look at this example. The graph shown here is the sketch of the curve with equation y equals fx. There are 4 marked points. The coordinates of these points A, B, C and D are 0, 2, 1, 0, 4, 4 and 6, 0 respectively. All these points lie on the curve. Now, sketch the following graphs and find the coordinates of the points A, B, C and D after each transformation. So as we saw earlier, this is the graph of y equals fx and we don't know the exact equation of this graph. Fx plus 1. Here, 1 is added inside the function and hence this is the translation of the graph y equals fx 1 unit in the direction of the negative x-axis. So now this is the graph of y equals fx plus 1. Since the graph y equals fx is translated 1 unit in the direction of the negative x-axis, here we subtract 1 from all the x-coordinates. So the coordinates for a, b, c and d are now minus 1, 2, 0, 0, 3, 4 and 5, 0 respectively. Fx minus 4. Here we subtract 4 outside the function and hence this is the translation of the graph y equals fx 4 units in the direction of the negative y-axis. So now this is the graph of y equals fx minus 4. As the graph y equals fx is translated 4 units in the direction of the negative y-axis, we subtract 4 from all the y-coordinates. So now the coordinates of a, b, c and d are now 0, minus 2, 1, minus 4, 4, 0 and 6, minus 4. 3fx. Here we multiply by 3 outside the function and hence this is the stretch of the graph y equals fx by a scale factor of 3 in the y direction. So, all the y-coordinates are tripled. Now, this is the graph of y equals 3fx. As all the y-coordinates are tripled, the coordinates of the points a, b, c and d are now 0, 6, 1, 0, 4, 12 and 6, 0. f2x. Here, we multiply by 2 inside the function and hence this is the stretch of the graph y equals fx by a scale factor of 1 over 2 in the x direction. So here all the x-coordinates are held. Now this is the graph of y equals f2x. As all the x-coordinates are now held, the coordinates of a, b, c and d are now 0, 2, 1 over 2, 0, 2, 4 and 3, 0 respectively. Now let's take a look at another example. The graph shown here is the sketch of the curve with the equation y equals fx. The curve crosses the y-axis at the coordinates 0, 1 and has a vertical asymptote with equation x equals minus 2 and a horizontal asymptote with equation y equals 0. Now, sketch the following graphs and in each case state the equations of any asymptotes and if possible points where the curve crosses the axis. So, minus fx. This is the reflection of the graph y equals fx on the x-axis. Now, this is the graph of y equals minus fx. Since the graph y equals fx is reflected on the x-axis, the graph y equals minus fx now crosses the y-axis at the coordinates 0, minus 1. Here the graph doesn't cross the x-axis and the asymptotes are still x equals minus 2 and y equals 0. F minus x. This is the reflection of the graph y equals fx on the y-axis. Now, this is the graph of y equals f minus x and as you can see, the coordinates in which the graph crossed the y-axis didn't change, it's still 0, 1. And the horizontal asymptote is still y equals 0. But as the graph y equals fx is reflected on the y-axis, the vertical asymptote now is x equals 2. It's also reflected. 2fx. This is the stretch of the graph y equals fx by a scale factor of 2 in the y direction. So now all the y-coordinates are doubled and hence this is the graph of y equals 2fx. As all the y-coordinates are doubled, the graph now crosses the y-axis at the coordinates 0, 2. The asymptotes are still x equals minus 2 and y equals 0. Fx minus 2. This is the translation of the graph y equals fx by 2 units in the positive x direction. Now, this is the graph of y equals f x minus 2 as the graph y equals fx is translated by 2 units in the positive x direction. Here we add 2 to all the x coordinates. So now the vertical asymptote is x equals 0 and the horizontal asymptote is still y equals 0. The graph y equals f x minus 2 doesn't cross the axis. The original y equals fx graph crossed the y-axis at 0, 1. But for reference, if we take this point, the coordinates of this point in the y equals f x minus 2 graph is now 2, 1.